So my name's Mark Rushton, and my session is called Design for Profitability, so hopefully that's not over-promising. It's kind of a big title, bold statement maybe. And it kind of started off as a bit of an experiment to see what was possible by combining some of the different tools in SolidWorks. And I'm just going to share those results with you. So yeah, I'll leave it at that. And that's a good start. My clicker doesn't seem to be working. All right, I'll just use the mouse. Okay, that's not working either. It was all working fine a minute ago. I've not had that before. I'm in a different mode.
Yeah, like go click on
the read one.
Yeah, the read one. Try it now.
Oh yeah.
Good enough?
Yeah, I guess. Thanks, Chris. Let's see. Oh man, that sucks. Oh. Yeah, my slides were not progressing. Oh. I mean, I can use the read mode if I need to.
Yeah, that's weird. Can you think of what's wrong? The PowerPoint one advance? Yeah, that's pretty weird. I'm not even getting the menu down here. You tried restarting? That's probably the right answer, to be honest. You
Okay.
want to try restarting?
I'll just use the reading mode and then just click it. That'll work.
Sorry about that.
No worries. Okay. That's a good start. But no worries. Okay. So I've put up a little few poll questions just to kind of gauge the room. So if you can just go to slido.com or use the QR code and then put that code in. There's a couple of questions just to kind of get a sense of who's in the room, not personally, but what type of people we have in the room. And that's me. And so I'll just leave that on the screen for a minute. So yeah, my name's Mark Rushton. I work for a company called A Priori Technologies. Cover those briefly, but that's not the main purpose for me being here, but they did kind of sponsor my visit. So just give them a little shout out. So yeah, my background, I used to work at SolidWorks for 7 years. So this is my 9th appearance at a world venue, twice as a non-SolidWorks employee. So hopefully you're all into there. So A Priori Technologies, we'll come on to the poll questions in a minute. A Priori Technologies, we're a software company, SolidWorks partner. So we'll read in SolidWorks files. We also work with other CAD files, but we won't mention any of those today because of where we are, but we'll read in any CAD file that you need. And really our mission as a company is to help our customers do a lot more for every dollar they spend on manufacturing and designing their products, and also reducing the environmental impact. So there's three main pillars to what A Priori does. We work out how much something should cost. We check it for manufacturability. We also give you a carbon footprint and assess the sustainability just from the CAD product and a couple of inputs. We support over 200 of the kind of manufacturing leaders in manufacturing. Some quotes from customers. So Caterpillar actually saved $1 million in an hour. Seems like a crazy quote, but it's from them. They actually did save that much by negotiating supplier costs based on what A Priori told them it should cost. Danfoss consistently saved 20 to 30% on new product introduction. Alstom use our technology. They've actually got an initiative called Zero RFQ, where they kind of worked out with their suppliers how much things should cost. It's all agreed. They use A Priori to work that out, and it means they don't have to do any RFQs. They just send it out, and they know how much everything's going to be how much it's going to cost. And we've got some very big name manufacturers. Headquarters is just outside Boston, Massachusetts, and we've been going for 15, 20 years, so quite mature. So what we're going to talk about today, the importance of designing to a cost and being aware of cost at the design phase is what we're going to cover. Then we're going to look at design for manufacturability and how much it influences cost. Then we're going to do some demos of all the DFM checks inside SolidWorks. Then we'll have a look at SolidWorks costing very briefly. And then my kind of experiment was to see if we can pair the two tools together, looking at DFM to kind of quantify the design for manufacturability. By adding this feature, is it going to increase the cost or increase the value? That kind of thing. That was the question I really wanted to ask. And then we'll summarize just with design for profitability, the name of the session. So just to get a sense, really, we'll just go to the poll. And if I launch that, the first question is, how many of you are involved in evaluating the cost of designs? Is something I wanted to kind of gauge. So there's a few different answers. Hopefully they should appear on your phone. But basically, are you involved in answering RFQs? Do you set target costs? Are you responsible for setting those target costs? Are you the boss? Is there nothing really formally in place for that? All those kind of things, just to get a sense. Okay. All right, and we'll come back to that, but it looks like the vast majority are working on the design, kind of aware of what's the most cost-effective way to manufacture something. So that's kind of what I expected, really. Okay, so, I can click now. Interesting. Huh, I can not be a hunchback. Right. So the importance of design to cost is really, you want to have some awareness of cost right up front, because that's where you can make lots of design changes. You've got far more design freedom. You can try out lots of different alternatives, because the closer it gets to deployment and manufacturing, the cost of making changes goes up immensely. I'm sure you're all aware of that. And there isn't a kind of direct quote. It's kind of just one of those laws, but 80% of a product's cost is determined in the design phase, and the same is said for environmental impact as well. So if we drill into that, it's interesting to look at where the biggest influence of cost is relative to where the cost is incurred. So design, in terms of its cost, is usually around 5% of the product cost is from the design phase. But when we look at the shadow that's cast on the product, that's, as we said, is around 80%. Then there's the material selection. So that's usually around 20%, and the influence over that is around 15%. Then when it comes to labour, they don't have much influence over the cost, but it's around 15% is what they add to the cost of the product. And then overheads, keeping the factory lights on and warm and stuff like that, that's generally contributing about 30%, again with very little influence on that. And I tried to look for some quotes to kind of figure out what percentage or what influence design for manufacturability actually has on the cost of a product. And there weren't many out there, but one quote was around 20 to 30% of costs, and then 50% elsewhere. I think it's quite hard to kind of judge. So another poll, just to kind of carry on from that, is do you have kind of a formal process for reviewing how manufacturable a product is? Or is it just down to the designer to use their kind of expertise? Or do you have like a design review specifically on DFM? So if you could just fill that out. I can only explain one of the two abbreviations at the bottom on that one. There you go. Okay, so it's kind of what I expected. That's what we typically find. It's not usually a kind of a formal process. So it's definitely something to consider because it has such a big influence on the cost of a product, and with inflation, supply chain disruption, new regulations on environmental impact, all these things kind of make things a lot more difficult for a design engineer. And so to be as efficient as possible, we really want to use some of these DFM checks. So what I wanted to cover, I've got demos lined up for all of these. So DFM Express, we've got go through a range of examples. Hole alignment tool, thickness analysis, interference detection, draft analysis, and undercut detection. So we'll start off with DFM Express. So DFM Express is on the Evaluate tab of the Command Manager. If you don't use the Command Manager, because you're a long-time user and you never wanted to change in SOLIDWORKS 2008, you'll find it under the Tools and then Express Products. So you'll find DFM Express in there. Now, if you haven't used it, has anyone used this before? Okay. So that's good. If you haven't used it before and you're on a relatively new version of SOLIDWORKS, you do have to go through this little activation kind of rigmarole. So you get given a code, and then you have to go to My SOLIDWORKS to kind of validate that code, and you're given another code, and then you put that into SOLIDWORKS just to activate them. So it's a little bit annoying, but you can get it, and there's some good value in this product. So we've got our design here, probably a machined part, something like that. And what we can do is go into the settings. So the first thing we'll do in DFM Express is go into settings. And this has got a number of checks for manufacturability for different processes. So there's 4 different processes here. The first one is milling or drilling. We can also do turning with mill drill operations, sheet metal parts, and injection molding. And based on the manufacturing process that we choose, we've got a series of rules that we can check against. So for milling, these are my rule parameters. Now, the ones out of the box are actually not too bad, but if you go and speak to your supplier or your manufacturing team, shop floor, whatever you refer to them as. You can probably get some more accurate figures for you. So the first one for mill drill is hole depth to diameter ratio. And essentially that avoids us from using a very deep hole with a very small diameter, because the tool's likely to break. It also works the other way as well. So if we've got some very wide holes that we'd need a really big tool for and it's just not efficient, it does those kind of checks for us. And all of the checks, and that's what DFM is all about really, is just making things sensible and efficient to manufacture. We can also look at the minimum percentage of hole area inside a part, because, you know, do we really want to be cutting all that away? Mill tool depth to diameter ratio, so milling as well as drilling. Percentage bore relief, linear tolerance zone, all stuff like that. We can also edit our standard hole sizes. So this will check if we're using any non-standard hole sizes. So if you're doing a particular weird size hole, you're not going to be able to just get a drill and do it. You'll have to mill it and do some weird stuff. So you can actually specify what your standard hole sizes are. And it runs pretty quick. You can just hit run, analyzes the model, and it shows you all the rules that have failed with a big red X, and then all the rules that are passed in green. It does minimize those, because who cares, you've passed them. You never need to look back, just like your exams. But the ones that have failed kind of show up at the top, and you can actually get an instance, and it'll highlight on the screen where those dodgy features are. So the first one it's flagged up is the hole depth to diameter ratio. These are not particularly deep holes, but they're quite big. So it's saying the hole depth to diameter ratio is 3, so you might want to look at that. And it's also pointing out that I've got some fillets or radii on the outer edges of my part, which is just going to add cost essentially, whereas I could just leave them as the original stock that I purchased potentially. So yeah, really quick, and it's given me all of those options. We've also got some different settings, so we can look at the sheet metal one. So if I open a sheet metal part, it would make more sense. So then we can go to sheet metal. We've got a different set of rules. Some of them are the same, like hole depth to diameter ratio, but it also checks things like bend radii, and any holes or distances, countersinks that are close to an edge, because it's obviously likely to tear and stuff like that. So you can very quickly run that analysis. This is quite a complex sheet metal part, but it does run pretty quickly, and it will flag up where all my rules have failed. I said it does run fairly quickly. So yeah, that's a good one. The injection molding check is just a thickness analysis. So for injection molding, excuse me. For injection molding, you just want a constant wall thickness as close as possible. So that's the check that it runs. And it will come back. So here we can see we've got some simple holes that are quite close to a part edge. So if we can't see them, you can just right-click and do zoom to selection, and it will find where those failed checks are as well. Okay. Yeah, so that's DFM Express. So we've got hole depth diameter ratios and milling, turning checks, things like that. Sheet metal checks, so extension and slightly different for sheet metal parts. And for injection molding, just checks for constant wall thickness. So pretty good for out of the box, just a little bit of activation to do. And if you, as I said, if you work with your manufacturer or whoever it is, then you can probably get some good figures and type those in. Any questions on that? Yep.
Is there an API for this? Is this something that could be automated as part of a workflow where you just get like a pass-fail? And if you get a fail, then you have the designer go in and look a little more deep?
That's a good question. I'm not sure for DFM Express. I'm guessing, but I doubt there's any APIs for Express products, yeah. So, any other questions? Yeah.
Can you import your existing
Not with the Express one. You can't import them. It's just a manual typing it in for the Express products. Was there another question? Okay, cool. Right, so moving on to an assembly now. So stepping it up a little bit. And we've got a really neat tool that came in SOLIDWORKS 2009 for those trivia fans. At least I think it was anyway. And it's on the Evaluate tab as well, hole alignment. Now this one, to get this one going, it kind of messes with my head a little bit because you specify hole center deviation. And actually I had to look up in the help how to explain it because it's a little bit strange, excuse me. So it basically says if your holes are within 10 millimeters from one another, but they're not aligned, then tell me. So it's a little bit strange to get your head around. I guess if you've got lots of holes and you've got some that are fairly close, you might want a smaller tolerance on there. But it runs really quickly, hit calculate, and it'll go off and find any holes within different parts that are not aligned within that tolerance. So if you've done in-context modelling, it's very unlikely that you're going to have holes that are misaligned. But if you are just using standard parts and they've got holes in already, depending on how you've mated it, there might be some that are missing. So this is a really quick and easy check to make sure that holes that should be holes are aligned. Excuse me. So that's a really powerful one, and it's often overlooked. Has anyone used that tool before? Couple, okay, cool. Now the sort of holes it does check Hole Wizard holes, although for some reason it didn't check mine on this model, so I don't know if that's a bug or something I did wrong with the model, but it does check Hole Wizard holes. It'll check simple holes, cylindrical cut features, so if you just do a cut extrude and the holes are not lined up, then it will check those, but they're the only ones that it does check. So if you do like a different feature to do that. And I don't think it works on imported geometry either, so you'd have to kind of block the holes and then redo them. So the ones it doesn't recognise, multi-boundary, extrudes, imported parts, derived parts. So if you've used something like move, copy, body, or you've split a part, or it's a pattern, or insert part. So there's a couple of limitations that you need to be aware of. But in general, for kind of standard modelling, hole alignment's a really powerful tool. And just avoids all those errors on the shop floor and when things don't fit together properly. Or you could just use slots and then you don't have to worry. So interference detection, this is, for me, it's the reason you use 3D modelling. The reason you don't use 2D CAD is because you can use interference detection in 3D. So it's an assembly check. It's really simple to use. Question about API, I'm not sure if you can do it. I think you probably can, but interference detection is just something that everybody should be using in my opinion. And I'm using SOLIDWORKS 2022. This constantly gets added to. It's really good from the development team to see that they keep adding to this, because this is really the reason why you use 3D modelling. So if I just hit calculate, it will check the whole assembly. Excuse me. You want to make sure that you don't have anything selected when you do that, because if you have a part or a couple of parts selected when you hit interference detection, it will only check those that you've got selected. So have nothing selected and hit calculate, and it will show you all the interferences. If you've got a very big complex assembly, you might want to limit it and actually select what things you want to check for interferences. So take that with a pinch of salt. Then the results, if you can't see the result, there is a zoom to selection, like with the DFM Express tool. I can see it quite clearly here. I've got a problem with this fastener and the kind of plate underneath. So I've got an interference to deal with there. If you expand out the interference, you can actually see the two parts that are interfering with one another. So it's really, really clear that we're going to have a problem when it comes to manufacture this. So that's definitely going to put us in the more design alternatives where it's much cheaper to make changes to that design. So we've got loads of options in here as well. So we can choose to save out the results. We can also say, if we've got two parts that are touching one another, if we don't want that, we can actually say treat that as an interference, and we need to rerun it, but then we can go off and check the assembly for any components that are touching one another. So if you model to a specific tolerance, for example, rather than nominally, you might want to actually ignore components touching one another. If you do choose to ignore a particular interference because it's a fastener in a hole that you've modeled yourself, you can just hit the ignore button, but then you can also, and it just puts those in a folder essentially. So it still checks them, it just kind of hides them away. You can also say treat sub-assemblies as components. So if you've got a large assembly and you just want to say, I've already checked the sub-assembly, just see if my sub-assembly is interfering with any of the parts. There's a checkbox for that. And a recent addition is this create a matching cosmetic threads folder. So if you're using the Hole Wizard and you've got a cosmetic thread on there, and you've got a toolbox component with a cosmetic thread, they will interfere because they're modeled to the biggest size. But you can actually get it to check the cosmetic threads match, which is pretty powerful. Sorry, my throat's gone all dry. So yeah, that's a pretty powerful one. And you can also say anything that's hidden, you can choose to ignore those, whether it's a body or a component. So if you model all of the tooling and stuff in your assemblies and you just hide them, whatever that might be, you can just say don't ignore anything that I've hidden. So really, really powerful tool, loads of options that you can look at. But yeah, it's going to save you so much time on the shop floor and avoid any errors and stop you getting shouted at, basically. So yeah, many options, as I mentioned. You can treat coincidence as an interference. You can ignore some. You can treat sub-assemblies as components. You can also include multi-body part interferences. So if you've got a multi-body that's got interferences in, it'll check those. Anything that is interfering, you can choose to make transparent so you can see it easier. Fasteners, you can say create a fasteners folder, and it'll ignore those because they're modeled nominally, as I said. It'll check cosmetic threads, ignore hidden stuff. And a recent thing, you can actually sort them by size. So the biggest interference you can actually show at the top of the list. That's another quite recent addition. But zoom selection is really powerful if you can't see where the interference is. So that one's a must-have if you're not using it. Then for injection molding, so there's two really powerful ones. There is thickness analysis in SolidWorks as well as the DFM Express. There's a little bit more configurability in that one. But draft analysis and undercut analysis are the main ones that will influence your cost. So we've got this part here. And draft analysis is also on the Evaluate tab. And this is really nice because this is actually dynamic, so I can keep draft analysis on while I'm modelling. How many, just out of interest, how many people here actually put draft on their models for casting and injection moulding? Oh, quite a lot, okay. I've seen it a lot where people just kind of let the manufacturer deal with that. Yeah. But the big question here that you may know, but I certainly didn't when I was doing design work, is how much draft do I actually need? It varies massively on the type of machine that you're using, the material you're using, all kinds of stuff. So that figure is the key, really. If you don't know what that is, draft analysis is not particularly useful, but you can put a nominal figure in there. So you have to choose a plane, so you have to have a rough idea of where the mold's going to split for casting, die casting, or injection molding. There's a couple of options. You can have a kind of gradual transition if you want to see the colours kind of blend into one another a little bit. And you can control these colours if you can't see them particularly well. Like if you're red, green, colourblind or something like that, that might be useful to change. Yeah, I'll leave them as is. If you are not quite sure the best angle for the tooling split, you can use this adjustment triad. And what that allows you to do, it gives you this widget type thing where you can actually change the kind of draft, the split line by a certain angle and just see how that changes the design. So this might be quite useful if you're not quite sure where to split something. You can kind of tweak the angle and try to find the best angle to split the tool from. I won't use that on this one, so I'll just reset that back to the front plane. And it stays on, so I can use all of the tools in SolidWorks, carry on modeling, and this will update. So if I was to add draft onto this face, and I've got the required angle, that will turn to green, red, whichever colour it's supposed to be. So it really gives you an idea of where you need to focus. And as you can see, by hovering the mouse over different faces, it's actually giving you a dynamic readout of what the angle is at that point. So that's a pretty useful tool if you can deal with the colours while you're modelling. An undercut analysis. So undercut analysis is something that was kind of drilled into me when I was doing design work, not the analysis tool itself, but when I was working with an injection mold tool manufacturer, they're like, how are you going to manufacture this? You've got all kinds of undercuts. You've got to think about how it's going into the tool and how you're going to get out, all stuff like that. So again, a really useful one. This one is, I don't believe is dynamic, but it kind of works in a similar way. We've got an adjustment triad in here as well. It works very similar to draft analysis. Oops, let's turn off draft analysis. There we go. So I can, it actually might be dynamic. But I can see exactly where I've got an issue. So if you imagine the tool is split across here, I've got one half in the cavity, the other half in the core. How am I going to achieve this? Because the motion of the tool coming apart is not going to allow me to do that unless I've got a side action to achieve those holes. So that's going to be way more expense just to do that. So if I can avoid that somehow, then that's going to save me a lot of hassle. Also here I've got this little snap hook type thing. It's telling me I've got this overhang, and it doesn't just do faces. You can see this is essentially just a shadow, so it's showing me exactly where my undercut is. Now for this one, it might be relatively easy to fix. I could probably just blow a hole straight through there, and that means I can have a part of the tool to fill that gap. But it looks like I might need to change the angle and stuff like that as well to do. So undercut analysis is probably another overlooked one. Many people use the undercut analysis here. Well, okay, yeah, a few. Cool. That's good. So yeah, two for injection molding. I say injection molding, but equally useful for like pressure die casting or casting as well. So draft analysis, really useful that it's dynamic, so you can kind of pull things around. And as I mentioned, undercut analysis really kind of does make a huge difference to tooling costs. So any questions on anything so far? Cool. Very good. So next up is a quick look at the costing module inside SolidWorks. So apologies, I'm not fully up to date with what level everything's in. I think costing starts in professional, SolidWorks professional, and then yeah, we'll leave it at that. I'm not trying to sell any licenses. So But the key for costing is in the templates. So if you want to get accurate costs out of SOLIDWORKS, you really need to dive into this and spend quite a bit of time setting it all up. So you'll find it's actually in a hidden folder. So C drive program data is the default directory for it, and then SOLIDWORKS, and then your SOLIDWORKS version. And program data is a hidden directory by default, so that's where you need to find it. And then based on the language you're choosing and costing templates, that is where they will be. Now, the default ones are all filled in quite nicely, but I had a look at some material prices, and I think they're a long way off. So you definitely want to look at that. I don't think you can trust anything that's out of the box as being close to reality, unfortunately. But they do show you how to fill it out, fill in the templates. So that's something you can definitely start from. However, you can speed things up. In the top right-hand corner, there is an import and export. So that will actually export to Excel. So if you go into the costing editor, you can go straight to export, and that will give you an Excel spreadsheet with the right template to be able to import it back in. So much easier to do in Excel. If you've got very similar grades and different stock types, you can use all the Excel functionality to do fill down and maybe even do some clever stuff and link cells to the right costs and everything. But then you've got to bring it back into to the costing template. And you can see if I limit this to only the materials that I purchase and use, then it will give me a kind of limited set that I can use in SOLIDWORKS, and you can tie the two together. So you've got different materials for different processes. So machining has got its own set of materials. Plastic moulding's got its own set of materials, casting, 3D printing, and also for weldments as well. So they've all got their own material requirements to fill in the costing template. And then cost is by weight usually in there. And then for each operation, this is, again, the secret to the accuracy is going through each operation and really putting in the feeds and speeds, but also material utilization. Now, this is quite a difficult one to generalize because you're basically saying, based on the body, the volume of the body that I've got on screen, what percentage is wasted. So that's quite difficult to do, particularly if you're doing like sheet metal parts, because it depends how they're nested. So that one is kind of just a rule of thumb maybe. So for injection molding, maybe it's around 5%, something like that. But that's definitely a difficult one to fill in. And then you can also limit what machines are available. So you can choose to put in the template what processes you've got access to. So in the standard template, we've got drill, mill, and a machining center, and you can choose which kind of sub processes you've got. Then you've got machine cost per hour. So again, there might be something you probably don't know off the top of your head. There's also labour cost rates, but the feeds and speeds and how long things take to set up is kind of fairly limited what you can actually put in here. So that's just something to bear in mind. And the main kind of the main calculation is from feeds and speeds. So for all the different types of machines, you want to look at these in some detail and put in what speed and feed them, how quickly you can feed the material in, and how quickly the tool can run. So you do need to kind of spend quite a bit of time talking to your maybe supplier or manufacturing to work out what these are and what's realistic. And especially if this becomes very high volume, which is really where SOLIDWORKS costing, I think, is kind of well suited to, because time is a big influence over the calculation. So let's have a quick look. We'll just take a quick look at how it works. So we'll just go back to my kind of machined part example, and we'll just pull this up. So there's my very complex part, and I will go to my tools. In fact, I don't need to do that. I can just go straight to costing on my evaluate tab. Oh, okay. So that should be a transparent box. I'm not sure why it's not transparent, but we will soldier on. So yeah, what I've just got my regular part, and the first thing it will do is I can choose the method of manufacturing. So in this case, it's got machining, casting, plastic, which is generally molding, and 3D printing. So for machining, I can choose which template, which costing template to pull up. So if you've got different suppliers, you could have a different template, or different processes. You can set that up however you want to. And then to get to the template editor, you can launch it from there, or you can just find the template and open it. Then for the material selection, it will actually look at what material I've selected over here, and it will try and find it in my template. Now it looks like my plain carbon steel isn't in my template exactly as it is here, unless I've been playing around with it, and oh, it is in here. So out of the box, it will actually look at what I've selected and try and choose that one. If I want to play around with it and say, oh, I wonder how much something would cost if I use a 304 stainless instead, then I can actually push the material that I've chosen from here back to the SolidWorks model. So if I hit set material, it actually goes back to the SolidWorks model and changes the material for me over here. So I've got that as an option if I want to if I want to use costing to make my decisions. So also material cost is in here as kind of a variable, so it will just pull it from the template, but I've got the option here, if I know there's been a change, I can just override it and put in a different cost. So cost units is, in this case, is US dollars per pound, but we can use metric measurements as well. For steel, I think it's usually bought in a different unit, so you might have to do some calculation to work that out. But what it does automatically, it will find the right size stock to use. So it will try and fit a block over your part that you can then machine from. But if you know that you normally buy a cylinder or a plate, you can actually choose those instead. So if you think a cylindrical stock body is going to be better to use, then you can do that, or you can choose block or plate or whatever. And if you know what size you buy in, you can override those values, and you can also use the grab handles on screen just to drag it. So if you want to leave a bit of extra space for finishing or something like that, then you can make that a little bit bigger. Then all we need to put in is a quantity and a batch size or a lot size. So if I'm doing 100,000 of these and I want them in batches of 10,000, then I can just make the... I'm having lots of problems today. My delete key doesn't work. So yeah, I can change the lot size in here if I want them in different lots. I've got a shop rate as well, so I can add that on. And then a markup and discount, although I could only get it to do discounts. I'm not sure how you do the markup, but maybe that's just me. And then it'll go off and calculate a price based on everything that it's got in here. So in my feature tree over on the left, it's automatically attached a setup. So it's looked in the template, and for my setup operations, I've actually got 6, sorry. And that's because we're going to have to change the orientation of my part to do all of these and set up for each operation. So it does that automatically. We can choose to override these, or say there's no cost, or delete them out. So we've got some kind of flexibility if you know a better way to manufacture it. Then it's got the mill operation, so it's going to mill off the top face, then remove all of that volume as a kind of a second operation. And based on the time, and we can show the time or the cost, it works out the cost. Then we've got our hole operations, so the drilling, the hole pattern. If we want to add a custom operation like powder coating or something like that, we can choose to add that, add a custom operation in here, and it'll add the cost up. So that's where all the calculations are done, and this is where they're shown over on the right-hand side. So if this is my first kind of go, I can just choose to kind of set that as a baseline, and that just means it kind of gives us our starting point. So my starting point is $465 for this one. So then I can start to change it. So if I know my stock size is slightly bigger, we can change that and see how it affects the cost, and play around with different materials. So if I change this back to a plain carbon steel from my 304 stainless, it gives me an indication that it's 78% cheaper. So it's quite nice to get that instant feedback based on my template. So it really is based on my template. If the cost of the plain carbon steel versus the stainless is out, it's not going to be too useful. So need to make sure that the template is quite accurate. But as I said, this was kind of an experiment, really. So one thing I wanted to find out is can we quantify design for manufacturability? And I've realised the time, we've got about 15 minutes left, and I know it's me standing between you lot and several beers on Broadway, so I'll try and finish bang on time. So yeah, this was an experiment. So I thought, well, we can play around with draft analysis and reduce undercuts and things like that. That should bring the cost down, shouldn't it? So let's see how they play together. So let's go back to my, I'm just going to close this down for a second and go back to my injection mold part. So here we go. So I've actually got a series of different configurations to go through. So I've got my kind of door handle, bezel, and we'll go into costing. So we've done our DFM checks. We think we're in a good place, and we can pull this up. This one's going to be plastic. We can choose the template. And from our choice of plastics, in my template, I've got these 5 different ones to choose from. So I've got ABS, that should be what I've got set over here. This is ABS. I've got my material cost in here. And then we really need to know how we're going to manufacture this. So for moulding, we've got 2 options, hot runner or cold runner. So I think for ABS, then you'd probably want a hot runner system. And this is where the first part of the experiment kind of fell down a little bit, because I need to know the cycle time or the maximum wall thickness of the part. So what that really means is it's not taking into account much other than my maximum wall thickness. So that's definitely something to be aware of. I can do my thickness analysis and find what the maximum is, but unless I know the kind of accurate cycle time, the costing is going to be off, especially if we've got very large volume. Now, the other thing I mentioned was undercut analysis has a big effect on the tooling cost, so the mold cost. But that's the second thing you'll notice in here. You have to type in how much the mold is going to cost. So that's not going to come into the cost of my part. So I can make whatever changes I like. I can get rid of these undercuts. That's not going to reflect in this baseline or comparison figure. I really need to know how much that's going to cost. So it means contacting my supplier, getting a quote, things like that. Then the waste material, we need to fill that in. So again, we don't really know how much waste is going to be involved in the injection molding process. Probably depends on batch size and things like that. Then number of cavities in the tool. This does seem to make a little bit of a difference because it reflects in the time to manufacture it. and to how long it will take to reach my total number of parts. So yeah, that was what I wanted to find, really. So if we start with this as our baseline at $10 for this part, I then went and I thought, oh, what if I change the material? So I know for a fact that a polycarbonate, so we were on ABS. If we change to a ABS polycarbonate mix, we're increasing our impact strength. So that's good, but polycarbonate has a much shorter cycle time, so that should reflect in the cost. But unfortunately it didn't, because I have to tell it the cycle time or the maximum wall thickness, and all I've changed is the material. So it'll look at the material cost, and it didn't look like there was much difference. So my material cost in my template, which again could be off, was slightly different. So ABS was $1.15 per pound, whereas PCABS was cheaper, strangely. I thought that would be more expensive. And that's all that kind of showed in my change. So then I did make a change to the material, because PCABS, higher impact strength, I can make it thinner. And polycarbonate has a shorter cycle time, cools quicker, so that should be favourable for my cost. But again, it didn't really work out like that, unfortunately. And yep.
The cost comparison kind of resetting, should we calculate for every configuration?
Yeah, so that was the other thing. So the configurations, it's almost like a new part, so you do have to kind of set things up again. So it's quite useful if you want to try different manufacturing processes, but if you've got different configurations, it doesn't really work for the comparison. So something to be aware of. So then the other thing, I took out the undercuts here. I got rid of the snap hook. And again, that didn't reflect in my comparison, because that's only going to show in the tooling, unfortunately. So yeah, there's definitely capabilities in here that are quite powerful. I say for high volume, where the tooling doesn't really make much difference, then that's probably a good place to start. But yeah, and if you've got a way of getting this information, so if you know if you're using SolidWorks plastics and you can get a good cycle time, then you can build that in. There's a question in the back there.
How big is this part? And I'm just wondering where the cost is coming from, because there's no way there's a $12.
Well, that's it. It's all dependent on the material. So if my material costs are out, I've no idea how much ABS is per pound, and I'm just using the default ones. I haven't changed them.
So if the templates aren't good, then
Yeah, it's all down to the templates. Yeah, it's a calculator essentially. So garbage in, garbage out. But if you know,
salad templates?
sorry.
Is anyone's salad templates that have been validated to a degree?
That's a good question. I don't know. Maybe there's an opportunity for you there. So yeah. So I set out when I submitted the presentation. Can we use costing and DFM checks to quantify design for manufacturability inside SolidWorks? So design for manufacture is really critical for getting the lowest cost designs. It's all about efficiency. And there's some really great checks in there for high-level issues that are going to capture those and reduce your engineering change orders. And you really should build them into your everyday workflow. Almost like with you're writing a document. I mean, now it tells you when you've spelt something wrong or you've got grammatical errors. Just use it like a spell check. Just check where you've got something wrong. Choose the right checks for the manufacturing process and build those in. And then if you've got a good relationship with the supplier or the shop floor, or maybe you've got a cost engineering department, try and work with them to get some good figures to build into templates. They don't have to be exactly accurate, because it's very early on in the design phase. You just want some kind of comparison figures to know if you're going in the right direction or making things more expensive. And then for costing, it's really based on the material. So getting the material cost right, because it's looking at the volume. It doesn't really look at anything else. Production volumes and batch sizes do make a difference. So it's quite good for kind of cost reduction workflows, but with it not taking into account tooling, that's a significant investment that's kind of overlooked a little bit. So unless you've got very consistent tooling costs, then that's going to be a little bit tricky. But detailed feature costing, yeah, not the best, unless you've got a really accurate template and you keep that up. And that's the other downside, is making sure that it's accurate and up to date is something you're going to have to do. So yeah, considerations, limitations. You really need those kind of known values and limits for it to be successful. So knowing what you can manufacture or what your contract manufacturer can achieve is the key to it. Probably need some good monitoring of material prices. As long as things stay relative to one another, then it's okay if the whole market's up and down. But when you've got changes between different materials, that's going to be make things a little bit tricky. Probably once a quarter is probably a reasonable way to kind of balance the upheaval and the maintenance with what's practical. It's kind of a shame it's not all in the same environment. You'd think with it all being in SOLIDWORKS, you'd be able to kind of go back and forth between DFM checks and running the costing and have it all update. But you can see it had a little bit of trouble when I was changing configurations and rebuilding and things like that. And somewhat limited feedback in terms of you can only really compare from a baseline to the current design. So you can set a baseline, and then whatever changes you make, it will update, but you can't kind of track them and go back to an earlier design unless you're very disciplined at making those changes. So, yeah, definitely consider cost early on in the design phase. As I mentioned, it's responsible for 80% of the overall cost. And DFM is a major source of cost reductions. The quote earlier was up to 50%. It could be a lot more, but I think some of it gets stopped by the actual manufacturers themselves because they don't want to do it. We actually have one customer that sent out a design to a supplier, several suppliers, and none of them quoted for it. And the reason was they designed it in a way that it needed specialist tooling. And so nobody wanted to invest in the specialist tooling, and so no one quoted for it. So the cost is essentially infinite because no one wanted to make it. So without DFM checks, they couldn't move forward with it. And all of these checks I showed you is going to reduce in engineering change orders and any changes that manufacturing catch, and you have to go back to the drawing board, so to speak. So you're going to be faster to market if you can implement those. And really the approach you want to take is try and have these templates and all of your settings to reflect what goes on in the factory or your manufacturing facility. So think of it as like a digital factory, a digital twin even of the manufacturing facility. If you can make the two match, then you should be pretty close to quantifying design for manufacturability. So yeah, I really wanted to bring it all together, and it looked like the tools were there, but there's just a couple of limitations. But yeah, so DFM definitely does reduce cost. It's just we can't always tell by how much, especially if it's in tooling and things like that. But understanding how cycle time and production volumes can alter cost is quite useful. There's also regional differences, so you could set up a different template if you've got suppliers in different regions. Then you can take into account different energy costs and labour rates, things like that. But yeah, keeping up to date with material changes and labour cost changes is going to be a challenge. Getting specific values for DFM checks, that should be fairly achievable, and you can keep those up to date. They shouldn't change too much on a regular basis. And you can get close to using a should cost methodology to drive supplier negotiations. And you want your suppliers to be profitable, because if you lose a supplier, then that's going to be way more expensive than getting a really good price for a specific job. So I'm just going to go back to the Slido for one last question, and just to find out, is this kind of an area that you'd be interested to kind of explore a little bit further? Because I think we're kind of quite close with the tools that we've got available, but it'd be good to have an idea if it's something you'd be interested to explore further. And it's 5:30, so just wanted to say feel free to get in touch however you choose to. There's a QR code on the screen. So this will actually take you to the A Priori website. If you put in your details, we've actually got a DFM guide that you'll be able to download completely free. You just have to put in a couple of details so we can email it to you. And if you want to see if I can fix all my issues with technology, I'll be presenting again tomorrow, Wednesday 2:45. So I think I could probably say that's the headline act because that's after general session tomorrow. So if anyone's around then, it would be great to see you. But we'll be talking about balancing carbon and cost. So around sustainable design, related to cost and sustainability and getting the right balance. So thank you very much for attending. Thanks.